Next curve.
Hello, everyone. Welcome to this Next Curve Rethink podcast episode where we break down the latest tech and industry events and thingies, into the insights that matter. And I'm Leonard Lee, executive analyst at Next Curve. And in this Silicon Futures episode, we will be talking about Hot Chips 2024. Inevitably, something about Nvidia, and most likely their so-called delay. And, Karl's going to want to talk about the results, so we'll delve into that inevitably. And, of course, AMD's acquisition of ZT Systems and anything else my esteemed colleagues want to discuss. And yes, I am joined by the fabulous, Karl Freund of Cambrian AI Research, and the almost equally as fabulous Jim McGregor of the famed Tirias Research, which he's made sure that we are very aware of that he is with Tirias Research. How are you gentlemen doing?
We're doing good. We're doing good. But I would defer to Jim on fabulosity.
Are we going to get technical here talking about thingies?
Yes.
Thingies. Yes. Technical thingies, yeah.
All that matters. Actually, that might be a new quantum particle, class of quantum particles. You never know, right? I mean,
there you go.
Yeah. So, gentlemen, welcome. And before we get started, remember to like, share, and comment on the episode. Subscribe to the reThink podcast here on YouTube and Buzzsprout to take us on the road in your jog, your drive. And also check out and connect with Karl and Jim. And they'll provide their details toward the end of the episode here. So listen in, stick around, and I guarantee you will learn something, because when I have Karl and Jim on, there's nothing but truth bombs and Buddha bombs being dropped related to what's going on in the semiconductor industry. So, gentlemen, shall we get started?
Let's do it.
Shall we get started with the bombardment? Yes. So let's start off with, why don't we? Hot Chips 2024, which we all attended. I was there for the first 2 days, and you gentlemen somehow managed to make it through all 3 days. It was really chock full of a lot of presentations, a lot of stuff, So who wants to go first? What was your take? What were the highlights? What do you think the audience should be aware of in terms of the future of semiconductors, and of course, our favorite topic, generative AI?
Well, let's talk about what Hot Chips is first, for anybody that's not familiar with it. Hot Chips is a conference that's been around for a couple decades, and it's kind of morphed with the industry. It's always been a very technical conference. It's not one where it has an expo or anything like that. It's really focused on talking about new semiconductor technologies, the underlying technologies, the semiconductor technology that makes them, and the chips. And we've seen it morph over time, according with the industry. Obviously, it started out focused on CPUs. We saw a big introduction around GPUs and DPUs and other types of accelerators, even talking about FPGAs and stuff over time. Now obviously everything is AI. It continues to be one of those key conferences, and there's a couple of them out there like ISSCC and IEDM, where Hot Chips is the conference to really go and talk to some of the lead architects of these technologies and the chips and see what they're working on. Sometimes you'll get, introductions of new chips like we saw this year, and we'll get into that. Sometimes you'll get a deep dive on some of the technologies that go into these chips, and we saw some of that this year as well. So that's kind of an overview of what Hot Chips is, and it continues to be a very important conference for the industry, and it was very well attended this year.
Yeah, it was.
Yeah, it's always interesting to see Hot Chips presenters go really deep, and sometimes so deep it's just right over my head. This year there was less new stuff. I think there were some new technologies, many of them were just diving deep in technologies they've already announced. So, for example, Qualcomm had the ex-CEO of the company they acquired to build their current generation chips, and he went deep. He went deep into the, how many registers and what does the memory bus look like and all that kind of stuff, right? But less new stuff, fewer new chips, really new chips. IBM was one that did a new chip, a new mainframe chip, and the new AI accelerator, which came from IBM Research, that is very efficient for doing large language models. And that gives the mainframe user now access to doing large language models, the next generation mainframe, I should say.
Yeah, and Jim knows a lot about that new IBM chip, right? Don't you?
I do. Well, I think we both do. But, there was, just to get back to Gerard from Qualcomm, having him there was kind of an honor, because this is a gentleman that, came from Nvidia, started Nvidia, actually started the development of all the Apple chips. So, long history. So a lot of those mobile devices. And he went into the Oryon core, which is going not only into the latest Snapdragon X Elite chip for PCs, but Qualcomm's already indicated that technology is going to be going into everything from XR headsets all the way through automotive, and it's impressive because thinking of it going into mobile, and there's not many changes from when they were working out in Nvidia as a server chip. So it's still a very, very impressive chip.
Yeah, one of my big takeaways from his presentation, even though I'd say 80% of it went over my head, was his focus on scaling, being able to scale the architecture. But then also, it was interesting during the Q&A. I thought it was really noticeable and notable that he oftentimes made statements about how less is sometimes more, and more is not always more in terms of the design choices that you make. And so certain cache sizes or, certain types of aspects of the architecture and the way he designed things looked at certain objectives in a way where maybe from an outside observer, those choices didn't make sense. But this idea of just really focusing on the efficiency of design and how sometimes doing things that, let's say, from a speeds and feeds perspective might look like from an engineering perspective, less is actually more at a system level. So I was like really fascinated by his thinking, and the way that he was rebutting some of the questions that were coming at him during the Q&A. So I just wanted to put that out there.
Actually, the term you're looking for is balance, and having a balanced design. As a matter of fact, he's not the only one to mention it. We saw that throughout several presentations throughout the 3 days, or especially the last 2 days focused on products. And that is unique because typically in the past, we've seen companies rush to get products out there, because they're pushed on time to market. And they put as much memory, they put, the highest speed interconnects, they put, as many cores, they pack as much as they can, knowing that they're not going to get their entire, itemized list of features that they want to put in there. And then the next one or two generations, we kind of see them tweak that design to where, it's kind of optimized. It's more efficient. So they're getting rid of inefficiency, increasing performance, we see a lot of the companies now saying that's not feasible anymore. So they're doing a lot more working with the EDA tool vendors, Siemens, Synopsys, and Cadence, to use their tools for design, validation, analysis, all these things up front and simulation to figure out what that optimal design is. And you're right. Sometimes you may look and say, well, why didn't they put, maybe another core here or do this or do that? And quite honestly, a lot of it comes down to the fact that they're doing a lot of that optimization up front now. And we're seing that effort really come through in some of the products.
And we saw it with IBM, right? The Telum II chip, where they did the analysis that the addition of AI processing would make the chip I/O bound. So if you just have the chip access an onboard or offboard accelerator for AI, you're going to find you just can't get data in and out fast enough.
Yeah.
And so they actually took the space of a core, a new core, and they said, no, we're going to put an I/O processor, an I/O accelerator on the chip to get the data in and out of the beast. Instead of having another chip, another core, it took up like 1.5 cores worth of space on the chip.
Yeah.
And they dedicated that to the I/O, to, as Jim says, to create a more balanced design.
And in addition to that, they added the DPU, so kind of that workload, overhead workload accelerator on chip. And they linked, and this was kind of an important part, they created the ability to link those accelerators between chips, those AI accelerators. So you can actually create kind of a larger AI accelerator between multiple chips in a system, in a rack, whatever. So it definitely, I mean, you see a lot of that effort coming into creating a more balanced solution, and not just at a chip level, but at a system level. That's kind of the other key takeaway here is everyone now is figuring out, how do I build a better system, or how do I build a better data center?
Yeah.
And, you know, and we see that come through in some of the design choices they make.
Yeah. And, you know, I don't know what your reaction to this is, but I also felt that the Telum II and that whole series of processors and systems, which are really geared for the mainframe, also were exemplified this movement toward examining what does enterprise AI look like, right? So if you, and that's a bit of a blending of the old and the new, but it's almost connoting a different type of system architecture. And that is different from what we're seeing coming out of Nvidia, which is largely focused on this incredibly massive supercomputing capability for the training of models. And then, you know, with this thinking that it will also be used for large scale inference at some point, right? But those are like different tracks that seem to be, you know, streaming off of a common origination point, which is what Nvidia is doing with the GenAI supercomputing.
Yes and no.
Yeah.
Yes and no. I mean, you have to remember that IBM also introduced the Spectre AI accelerator card. So they're going to be able to populate these mainframes with a boatload of accelerators for doing. So they kind of position as, you know, the traditional AI stuff or machine learning stuff is going to be done on chip, and then the generative AI, those big models, are going to be on the Spectre. NVIDIA, you got to remember, is mostly focused on the accelerator side, so the AI side, where, you know, IBM is more in line with, I would say, AMD and Intel, where they're trying to create that balance between the CPU and the accelerators.
There's that word again. There's the
balance. It's all about balance.
That's going to be like the new big word over the next 12 months. Balance. Okay, cool. I like it.
I was happy to see Enfabrica again. They came out of stealth a year ago at AI Hardware Summit.
Yeah.
Next version of which taking place a week from Sunday, actually. And what Enfabrica does to the data centers, akin to what NVLink does to a rack or a DGX, Enfabrica is basically providing the SuperNIC capability that takes everything on the network side of the GPU and makes everything work much more balanced. But it rips a lot of cost out. But the interesting thing they talked about was RAS. If you take a product that has maybe a 5-year MTBF and you flash together 100,000 of them, your MTBF is now measured in hours of the total system, which means you have to do a lot of checkpoint restarts on your training job because you don't want to start all over. And so what they're doing is saying, look, use our platform, and if a node goes out, you just route around it. You'll just use a different path to get to the data you want or the processor you want. Very interesting value proposition. One that NVIDIA liked. They invested in Fabrica about a year ago. So it's an area. This is exactly why you go to hot chips. Is you get to see things like Enfabrica and get to know the details of the Enfabrica design and assess whether it can really solve the problems.
Yeah.
I'd say there were a couple other key takeaways. I liked, obviously, the nice thing about hot chips is you get to see the traditional guys, you get to see the startups, and you get to see the university stuff. And there were stuff on the university and startup side that was interesting too, like Ferosa AI, startup out of Korea that has a very unique architecture, even a different type of math to do, AI processing. So it was very interesting. Also, the fact that we had both Broadcom and Intel talking about co-packaged optics. So actually trying to get to chip-to-chip optical solutions. I'm kind of wondering when we go back to actually talking about backplanes, because I was at Motorola and we did optical backplanes 20 years ago. So it's going to be interesting. I think that optics is going to definitely change how we develop and architect systems. So they had two main tracks. One was on using AI for chip design, and will it replace designers? And the other one was focused on kind of advanced cooling solutions and techniques, what's required. The first one, there wasn't a lot of consensus. A lot of the different companies presenting, have different views on where AI should be used in chip design. I think the only thing they actually agreed upon was the fact that it's still early days, and this is kind of the first wave. In fact, even Nvidia, who's one of the first ones to start trying to use AI for chip design, is really not even using it for the chip layout yet. They're still working from analysis back in 2019 to really validation at this point in time, and not really using it for creating that physical chip design. The latter one, talking about the cooling solutions, Supermicro presented some great data there where they said, just going to liquid cooling solutions, you can save 92% of the cooling power created in a data center and 40% of the overall data center power. So, very strong case for going to liquid cooling on these next generation solutions. And we're seeing that both from the chip and the system vendors, push for more liquid cooling type solutions. So it was very interesting. And matter of fact, even on the cooling solutions, we saw that from the edge with companies like Qualcomm and a couple of startups talking about some of their unique cooling solutions for edge solutions, like smartphones and PCs and everything else, all the way up through the data center.
Yeah, and I thought that was really interesting because it seemed that a lot of the gravity was being distributed across, let's say, the supercomputing side of things, or HPC, and let's say endpoint like smartphone. But I thought that presentation was really cool because it started to address the stuff in between, right? So let's say an intelligent gateway for industrial, where you might want to deploy a larger, let's say, AI application or a larger model footprint to execute on the edge, and then being able to provide that next level of cooling dynamic to evolve solutions in the middle. And I think that's going to be really important going forward, because that's what's really going to change the dynamic of what, quote unquote, all this talk about hybrid AI is going to be about, right? So yeah, I'm glad you brought that up, Jim. And one last thing, I think there was a lot of, I mean, this is my first time going, but I know that over the course of the year, there's been a lot of talk about data precision. And one of the things that I thought was really interesting, Karl, you and I have talked about in previous episodes of Silicon Futures is, what Nvidia announced with their, what is it called?
Quantization.
Huh?
Quantization.
Yeah, quantization.
using lower precision. You don't need a quantum computer to do that.
Yeah. No, not quantum computer, but yeah, exactly that. They announced Quasar quantization system and research. It's something that we kind of know about, but they've kind of bundled the overall framework and research framework that they use to continue to
Yeah.
progress and advance that particular leg of Huang's law. So
Yeah, one of the key differentiators NVIDIA enjoys today and will enjoy with Blackwell is is their low precision floating point, their 4-bit float. AMD doesn't have that, which means that at least from a benchmarking standpoint, we'll talk about benchmarks more in a moment. You can double the performance with 4-bit float versus 8-bit float. Now, AMD doesn't have 4-bit float, so NVIDIA said, well, we better make it easy to use.
yeah,
And that's what Quasar is really all about. It's really about making it easy or easier to quantize your models and be able to take advantage of the efficiency of low precision that NVIDIA has that their competitors don't have.
Well, there was a focus definitely this year on different levels of precision below 16-bit, which is kind of unique for AI. Previously it was all 32-bit, 64-bit. We're slowly inching our way down. But AMD had MX6 and MX9, and different people talking about. It seemed like everyone has their own different levels of, I should say, optimized data configuration. So it's going to be interesting to see how that plays out. But I agree with Karl. The tools and the resources and the investment that they have in doing all of these things, from foundation models to quantization to all the way up to Omniverse, which is kind of an operating system for the cloud. It's impressive, and NVIDIA is continuing to push the limits.
Yeah.
Now, during the hot chips, ML Commons release and latest version of MLPerf. This time around, it's inference processing. And after years of pounding on Mark Papermaster for not producing MLPerf, they finally did. And so my hats off to the AMD team for delivering really good performance on inference processing. Now, they've been saying you're 20 to 30% faster than Hopper. And I point out, well, that's not an AI application statement. That's a micro benchmark statement. And sure enough, they're not 20 to 30% faster than H100. They're within a couple of percent of H100, which is pretty good considering they don't have the kind of software that does the optimization that NVIDIA enjoys. So that's really good. And I think you'll see a lot more MLPerf type benchmarks come from AMD as their team becomes a little more mature, a little larger. They can afford the time to spend to do the heavy lifting it takes to optimize a benchmark like that.
Yeah.
NVIDIA also showed that Blackwell is up 4x faster than Hopper, which is pretty good. They're normally about twice, right? They're normally about every generation is about twice as fast as the old one. This time around, they're 4 times faster. But they were quick to point out that for inference processing on a large-scale system, Blackwell will be 30 times faster than the existing H100. So we'll see where that lands when they actually run the benchmarks.
Yeah. And kind of hold that thought on the AMD stuff. But hey, everyone, I think Karl's going to have a piece coming out covering hot chips as well as Jim. Through Tirias research. So stay tuned for that. And gentlemen, just provide links once they become available, and then we'll just let the entire world know about your wisdom and perspective on.
Just to let you know, I have kind of a day-by-day flow of hot chips on LinkedIn. So you can actually look at kind of reviews by day.
There you go. Okay, awesome. So we'll provide links to those links. All right. So yeah, let's talk about one of the big news items that surfaced since we last spoke, which is AMD's acquisition of ZT Systems, which I think was met by the public with a bit of confusion. I've seen a lot of pieces go out where, there's been some misinterpretations or let's call it misguided interpretations of what this deal implies. So, you two are probably the best folks on the planet to talk about this. So Who would like to start?
I think we should probably talk about the myths first, because acquiring a systems company, the first thought is, they're going to compete with Nvidia and their customers with, like a DGX style systems and stuff like that. And AMD has a much different strategy than Nvidia does. And, the manufacturing of systems, they're actually going to spin off, and they're going to keep the resources designed to design solutions around systems and help customers do customization on systems. So they are really focused on the system level of, feeding that expertise back into their chips, whether it's their DPU, whether it's their CPU, their AI accelerators, and help design future systems and future platforms and help customers do that. But they are not going to go as far as Nvidia is. Now, is that a better strategy or not a better strategy? We'll have to wait and see. What do you think, Karl?
Yeah, no, I think that's right. I think it solves one of their problems, right? They've got three problems. One is system, the other is software, the other is networking. It doesn't solve the networking problem. ZT doesn't bring any networking expertise with them. ZT, for those who don't know, that they provide servers for hyperscalers. You're not going to find the ZT system at Best Buy. These are systems that are spec'd by the hyperscalers, then designed by ZT, and then built by ZT. So that will definitely help AMD do a better job of moving up the stack. Mm-hmm. But it doesn't solve their fundamental problem of networking. And they're still 2 years away from having anything like an NVLink to interconnect the GPUs. Now, they do have the Freedom Fabric, but that's only to 8 GPUs. Mm-hmm. As AI becomes a problem that only thousands of GPUs can solve, they can't do that. And so they're partnering with Broadcom to do an Infinity Fabric switch, which will be really good. That specification for that's, I think, being released around now. But it's going to take a couple of years for that to turn into systems, silicon and systems. So it doesn't solve their problem, but it's a step in the right direction.
And they're hoping that feeds into the UA Link, where they're working with Intel and others to try to create an industry standard, just kind of competitive solution to NVLink.
Yep, exactly. I mean, everybody should keep in mind that AMD and Intel and everybody else is all Ethernet based. Mm-hmm. And so the moving Ethernet up the stack, adding RDMA, which is already available today, and adding higher performance and lossless fabrics and so forth, that's the kind of direction they're going, but it'll take time to get there.
Yeah, and the way I looked at it was a play to accelerate getting to solutions, through systems design expertise. And Jim, I think you alluded to it. They're probably going to spin off the manufacturing part of.
They've made that clear.
They've made that clear.
Right. And so and in that way makes it different than I think what folks initially thought it was going to be. But then also you've already spoken to it, but I just want to make it simple for the audience. Optimized systems, right? So bringing that expertise in so that the bits and pieces that AMD can contribute to a system that can be assembled in a blueprint through engineering expertise in an optimized way. And as all these standards, UA Link and such, once they come into play, they'll just fold in nicely, and then they'll be able to go to market. Hopefully, I guess they're hoping at a velocity and a level of aggressiveness that Nvidia has at the moment, right? Which is one of, I think, if you want to call it, you want to talk about the Nvidia moat, that's one aspect of Nvidia's moat, is this incredible go-to-market momentum they have, as well as inertia. So shall we move on to I think it's probably it was a few weeks ago, a big news item, but probably something that I'd love to ask you gentlemen, just to get everyone square on what this really means, is the Nvidia Blackwell, quote unquote, the so-called delay. Any thoughts there? I'm sure you have plenty, especially both of you.
Go for it, Karl.
The delay is to fix a yield problem. Okay. They can produce in Blackwell chips, but they can't produce enough of them. And the problem is the top layer of the chip, the metal layer, needs to be spun. Jensen said during the call on Wednesday, I guess, after earnings, that the fix is already known. It's in hand. It has taped out. So they have taped out a new mask set to TSMC. So they're just going to take a couple months to produce enough chips to be validated, tested, and put into systems. So it is a delay. They did write off a lot of inventory. And I was on the phone with investors this morning and said, why was it such a large write-off? Well, because they were swinging for the fences. They were trying to produce a very large number of Blackwell chips quickly as they could because their customers were demanding it. So they didn't get the yield they needed, so they have a lot of waste, and that of course has to be written off. My view is this is not a long-term issue. This is something that's going to be a couple of months. A year from now, will anybody even remember it? Probably not. So while it may have caused a blip in cost, it didn't cause a blip in revenue this quarter. They still beat the expectations, maybe not the whisper numbers, but they beat their expectations for revenue and gross profit. So I don't think this is a big deal. I think it'll be in the rearview mirror. It won't even be noticeable.
Yeah, I think describing it as a blip is probably the best way to do it. You have to remember that they're still in a long-term ramp of Blackwell. So it was still relatively small compared to Hopper, which will still be in production probably for the next couple of years. So, and their capacity limited across the board. So there's only so many wafers they can produce. So this was a very small impact on, their overall ramp. It's a very small, it's a delay in their ramp, if anything else, but it's a very little impact on them in terms of revenue or anything else, because they're still shipping as many wafers as many chips or I should say systems now, boards and systems, as they can possibly produce.
That basically puts that whole topic to rest then, right? Anything else to add? Oh, okay.
No, we did see an announcement recently. One of the vendors that talked at Hot Chips was Intel talking about Gaudi 3. And we did see an announcement where IBM's going to be leveraging Gaudi 3. So that was kind of significant, seeing that partnership between those two. IBM in the past has worked with Nvidia as well. So, and they purposely, with their recent architectures, have tried to support any type of accelerator. So very interesting to see Intel kind of land that opportunity as well.
Yeah, I was a little bit surprised. IBM's always said their cloud's different because it's all Ethernet, right? One of the things they're proud of is it allows them to virtualize workloads in their cloud. And so doing an Ethernet solution like Gaudi 3 makes a lot of sense. But the timing's interesting, just because Gaudi 3 is the last of its kind. They will move to the next generation, which is a converged GPU AI accelerator conversion to a single piece of silicon. But it has really good performance, and the fact that it's Ethernet makes IBM like it. And I think they probably got a pretty good price, I would guess. And so that's the first, maybe the only cloud instantiation of Gaudi 3. But it is a really good chip, and the software issues are working themselves out. It does not support one API, which is a bit of an issue for for Intel down the road. But it's a big win for Intel.
Actually, it's the second. They did announce one back in November. I can't remember the name of the company. It's not one of the largest CSPs, but it is the second major announcement they've made for Gaudi.
All right, gentlemen, all I can say is thank you. And to our audience, thanks for hanging out and listening in and making it this far. And I wanted to let these two gentlemen have an opportunity to share how you can contact them as well as engage with their research. So who wants to go first?
Yes, you can reach us through our website at tiriasresearch.com. Also follow us on LinkedIn. Like I said, some of the hot chip stuff I've been posting on a daily basis on LinkedIn. Follow us through all the social networking channels, obviously, X, as well as, find some of our articles and other videos and podcasts on YouTube, SoundCloud, as well as E! Times, Forbes, EE Journal, ECT News, and Microelectronics if you read Mandarin.
Wow. Okay. That's quite the list there, Jim. And how about you, Karl?
Yeah, the best way, just CambrianAIResearch.com, or follow me on Forbes, as well as all the social media outlets.
Yeah. And we'll provide links below for everyone's convenience. And so, gentlemen, again, thank you. Thanks for jumping on.
Thanks for having us.
It's great to have you on with Karl. It's fun. It's wonderful stuff. So, everyone, thanks for joining us, and please subscribe to our podcast, which will be featured on the Next Curve YouTube channel, which is where you're probably watching us. But you can also listen to the audio version on Buzzsprout, and from there you can subscribe, to any of your favorite podcast platforms. And also subscribe to the Next Curve research portal at www.next-curve.com for the tech and industry insights that matter. And until next time, everyone, take care. And gentlemen, thank you so much for sharing your insights.
Thanks for having us. Take care.